Time is, perhaps, the most profound mystery we encounter every day. It's the silent, unseen river that carries us from the cradle to the grave. We feel its passage in the changing seasons, in the lines that etch themselves upon our faces, and in the memories we gather along the way. Mankind's fascination with measuring time is as old as civilization itself. Long before the invention of clocks, our ancestors looked to the heavens for their timekeepers. The sun's daily journey across the sky, from its rise in the east to its setting in the west, was the first great clock. Ancient cultures erected enormous stone structures and simple shadow sticks to track its progress. The desire for greater precision drove innovation forward. Sundials were useless on cloudy days, leading to water clocks, hourglasses, and eventually mechanical clocks driven by weights and gears. Today we have reached the pinnacle of this quest with atomic clocks. These extraordinary devices measure time based on atomic vibrations and are so accurate they would not lose a second in hundreds of millions of years. Beyond measurement lies a question that has haunted philosophers for millennia. What is the true nature of time? Some thinkers, like Newton, believed in absolute time, a universal clock ticking for everyone. Others, like Kant, argued time is a structure of consciousness. Is time a real, tangible feature of the universe, or merely a framework we invent to organize our perceptions? This debate cuts to the core of our understanding of reality. This philosophical divide raises profound questions. If time flows, does the past still exist somewhere? Is the future already written? The philosophy of presentism argues only the present moment is real, while eternalism suggests all of time exists simultaneously. Now, for centuries, Newton's absolute time reigned supreme. But in the early 20th century, a young patent clerk named Albert Einstein shattered this comfortable picture forever, revealing that time is not absolute at all. Through relativity, Einstein showed time is elastic. It can be stretched and squeezed, and its passage depends on an observer's motion and gravitational field. The faster you move through space, the slower you move through time. Einstein's greatest legacy was unifying space and time into space-time, a four-dimensional fabric that can be bent and warped by mass and energy. This is the stage on which all cosmic events occur. This effect is crucial for modern technologies like GPS, which would fail without correcting for gravitational time dilation. The universe is far stranger and more wonderful than we had ever imagined. One of time's deepest mysteries is its directionality. We experience time as a one-way street, flowing from past through present to future. A broken egg will never spontaneously reassemble itself. The explanation lies in entropy, which is a measure of disorder. The second law of thermodynamics states that entropy can only increase. This relentless increase in entropy drives time's arrow forward. The universe began in an incredibly low entropy state at the Big Bang and has been expanding, cooling, and becoming more disordered ever since. This universal trend gives time its direction. This thermodynamic arrow explains why we remember the past but not the future. Creating memories increases entropy, allowing us to have records of more ordered past states but not the disordered future. The idea of time travel has captured human imagination for centuries. According to physics, traveling to the future is possible through time dilation. This is when an astronaut at near light speed would age slowly, leaping into Earth's future upon return. Near a supermassive black hole, time slows dramatically. An observer near the event horizon could return to find centuries have passed on Earth. The future appears accessible, but the past remains far more difficult. Traveling to the past creates causality paradoxes. If you prevented your parents from meeting, how could you exist to make the journey? Some physicists believe these paradoxes make backward time travel fundamentally impossible. Theoretical solutions involve wormholes or parallel universes, but these remain purely speculative. For now, the past remains a locked room, accessible only through memories and history books. While physicists define time with equations, our personal experience is far more fluid and subjective. It's shaped by emotions, attention, and age. We've all felt time fly when engaged in enjoyable activities, only to drag when bored or anxious about. This psychological experience is governed by the mind's clock, an internal timekeeper far from precise. When focused or having fun, our brain pays less attention to time's passage, making it seem to speed up. Age plays a significant role in time perception. For a 10-year-old, 1 year represents 10% of their entire existence. And for a 50-year-old, it's only 2%. As we age, each year becomes a smaller fraction of our total experience. Adulthood's routines mean fewer novel experiences for our brains to record, making years blend together and seem to accelerate. Understanding time's malleability reminds us that seeking new experiences can stretch our perception of time. Our journey through time's mysteries has taken us from ancient sundials to mind-bending physics. We've seen time as both a practical tool and cosmic dimension, a steady clock and elastic fabric, and lastly, a philosophical puzzle and psychological experience. Yet for all its complexity, our primary relationship with time is simple. We live it. We don't experience relativity in daily life, but rather a sequence of moments, one now after another. This ever-present now is where life unfolds. The past may inform us and future may inspire us, but the present is the only time we truly have. It's the point of power where we can act, learn and grow. By becoming more aware of this moment, we can change our relationship with time. The great river of time will carry on, indifferent to our understanding, but by exploring its nature, questioning it, and learning to appreciate its passage, we can navigate its currents with greater wisdom and grace. Time's secrets are not just for physicists and philosophers, they're for all of us. They invite us to see the incredible dance of moments that make up our reality. For in every tick of the clock, every rising sun and every breath we take, we participate in one of the universe's greatest and most profound mysteries.